All right, hey everybody. I got something really cool that I just couldn't hold off showing to everyone. A colleague of mine has been helping me a huge amount with this thing that we've kind of been referring to as streamed federation. And pretty much the concept is that I can get code from somewhere else. Like, it's not on disk, it's not requirable, it's from S3, it's from fetch, it's from somewhere else. And that's really useful for like local development, stuff like that, or even using CloudFront inside of like lambdas to federate your systems and pull them together under one lambda. Uh, but there's kind of always been a little piece missing to module federation, and that's mostly just because the things that I've built are just how I kind of build stuff. But the one piece that's been missing from this has been the true micro front end aspect. When you boot most of my apps, they run on two different ports, but the federation, there's one host. So if something breaks on that host, you can potentially, bring down the whole site. Even though the pieces of runtime are independently managed, you're doing the execution under one CPU under one thread. So, this has blast radius issues and global scope poisoning and other things like that that can kind of creep into the issue. And especially on the server aspect, it is more problematic there. Mostly because, sessions could bleed, or it's just harder to do. Like, mostly micro frontends are so that you have standalone servers that can run independently, that can share the load of the system. And with module federation, mostly what I do with it is I say, all right, there's all the other servers, so you can go and use them if you want, but pull all the JavaScript into one and run it like a distributed monolith. And there's been opinions on distributed monoliths, and I haven't been too concerned with that, but someone else brought up, like, well, how would you do this? Say in a Kubernetes environment. And in Kubernetes, this makes a lot of sense because you pay for the boxes already, so why not just use those boxes? So it got me thinking about how could module federation perform a task like this, where I want separate containers to handle the execution of federated code. I thought about using like workers and spooling workers on a single container, but again, that's still just a single container. And yeah, so it kind of had me stuck for a little bit. So I thought about it for a while, and then my colleague, Jacob, he pretty much helped me a huge amount get the whole streaming system up and running. So I spoke to him on Slack, and I'm like, hey, so I got this idea based on the streaming system that we had already. If we could modify it so that when we require a remote from your server, or require a remote on the server, how the streamed federation system works is we actually require a kind of chunk, but the module exports of the chunk is HTML. So pretty much I can do parallel rendering or distributed server-side rendering, but I still return the monolithic payload to the end user. I'm not having a bunch of promisols that I have to stack up or down and string replace in and out of an app. I don't have extra mount points or anything like that. I simply just want another computer to give me the HTML instead of my server handling the load of the whole system. And so this is really good for scale, especially if you think about boot times and just runtime overhead. And one of the awesome things that I've really thought about is like the fragment caching capability. So back in early React 16, I used to look after several fragment caches, and with those fragment caches, we were able to achieve, say rendering a product page with 48 complex cards on it. The general render time was about, I think, 15 microseconds. And the end-to-end response server-side rendered and everything was 20 milliseconds. And that's power and speed. And the biggest problem we had is that just React is slow at converting it into a string. But with the fragment cache capability, we could get around that quite well. But in the introduction of hooks and stuff like that, this became a lot harder to solve. However, now that what I'm about to show you exists, we can actually bring back half of the fragment caching architecture and run it slightly differently, which I believe if we do pull that back, we should be able to get sub-millisecond responses from any system, assuming that it's been executed before. So without further ado, let's get into this. So what I've got, and just bear in mind that this repo currently depends on proprietary code that is not publicly available. So we're still working out how all that's going to happen and stuff like that, but I'm just so excited to show the possibility of it. So let's get into it. So I have multi-threaded server-side rendering. I have website 1 and website 2. Looks very similar to my usual server-side rendering example. So to showcase a few differences in here, what I've pretty much got in my Webpack build is a slight change to module federation. So I'll go into server base because that's the only one that matters. And bear in mind that we only got this running last night at around 3 a.m. and it's going to be refined. But the fact that it runs is what I really care about, because I never thought you could do something like this so seamlessly. So we're going to improve it, but we've proved it can be done. So pretty much what I've got is a new plugin called Federated Runtime Plugin. And I have a HTTP runtime that I pull in as well. And typical module federation, of course. And I just have a little array up here with some remotes set to it. So now, if I go down here, I have the module federation plugin that's remotes. And then I have the federated runtime plugin where I pass the remotes as well. And then the actual runtime is the HTTP runtime. So the cool thing is that we also have an S3 runtime and a fetch runtime and so on and so on. That allows us to stream code from different sources. So with this setup, that's pretty much what we have. And then I'm going to hop into the app, and we have, some component that I'm importing. And this is from website 2. I'm currently looking at website 1. And, this is, that's going to make the little gray header. So it's pretty standard. However, the big difference between this one and my usual SSR example, which I'll show you, is this is a lot more conventional. So look at how I had to configure Webpack here. So it's really important to notice the module federation config for the server. See the difference? The remote, .. website 2. So I literally go up the file system and go back down, and I get the remote entry, and that's how I'm able to wire them together. Works really great if you have Kubernetes shared volumes, whatever, but this is still a distributed monolith. I still only have one CPU and one runtime available. So let's go look at this just one more time. And you'll see that I have remotes. If I look over at remotes, it's a slightly different setup. I'm able to pass website 2 is actually HTTP. So how I actually get the remote is different. So that's what we have set up, and it works both in module federation and it works on our extension as well. So with that out of the way, let's go and take a peek at what the server looks like. And the server definitely needs a little bit more cleanup, but I'm still very happy with what we did in the matter of hours. So yeah, inside website 1, there's really not anything happening. Like, I changed nothing. It's usually how it would render. And we could quickly just look at the source and go look at something like our bootstrap mechanism. Looks pretty standard. Yep. And app. So you can see there's nothing different. Like you can't spot on website 1 that I changed the implementation at all. The only thing I changed was I swapped out the Webpack plugin. Now we go to website 2. So website 2 is kind of the remote in this case, but it still runs on its own. They could be bidirectional, but it was a little hard to do in a couple hours. So what we pretty much have on this side is we have this middleware, and we have something called the edge handler, edge chunk, this edge setup. And if I look in my remote entry, so this is a really quick and dirty way to kind of pull this together. And what it is pretty much we recreate the Webpack remote entry on demand. And it's super simple to do, but we're going to condense this down and see if we can rewire this through another Webpack hook or through runtime scope or something like that. But the core concept is I have create remote entry where I generate a remote on the spot, and I actually attach the require IDs that I'm after. So it's pretty simple. Nothing too fancy here, just kind of a normal remote. But we're going to clean it up and recycle as much as we can. Now if I go over here and just look at our environment middleware. So down here in our little middleware stack that we have, I have, my index where I attach most of the middleware. And what I pretty much do inside of here is just one or two slightly different things. And that is pretty much that I'm going to pull in this edge handler middleware. And I'm going to create an edge handler. Now this is in website 2, so this is a remote. And what we're going to do is kind of compress this down a little bit more, and we're going to actually bind it to Webpack context so that the remotes are reconnected. So right now in alpha 1, what I do is I kind of pull in some component or the header component that I have, the exposed remote part. I create an edge handler. I have some middleware. I use a root called edge. This will pretty much help process when Webpack requires HTML from another micro-frontend rendering engine. And that's kind of how this piece is stitched together. Other than that, the code doesn't change. Your import, like your day-to-day use, you don't change anything. You pop this in here or a refined version of it in, and that's all you do. So let's get over to the running aspect now. All right. So why this is pretty cool is this is, website 2. It's just the header. It's interactive code. If I look at the source, there you go. Nothing fancy. It's pretty standard. But if I go to port 3000 and I run it here, it's pretty fast, but if I run it there, you're going to see down here in our engine that the host is saying that it's rendering and streaming these chunks into it. And when the code is executed, we have a little bit of JavaScript in there. So when the code's executed, it's saying pretty much I'm rendering on the server. But you'll see we never stream it more than once. So it works with the Webpack caching system. It's just as performant, all of that. So let's actually see how this is possible to happen. So we're going to inspect this here. And we're going to look at our network first. And cool. I see, 3001. So there's my header, hydrating perfectly, with no errors, no hydration errors, nothing. I'm going to view the source on this one, and you'll see, other than I need to do a little cleanup on that, you're going to notice that I rendered HTML here. Like, it server-side rendered the header. And now here's what's really special. Let's go and actually look at what's going on. So here's remote entry, the kind of thing that we kind of generated. nothing too big there. This is, you know, your typical like container, and it's all standard as well. But then I'm going to go to the edge. I'm going to go to the other side of this, the remote, where I'm actually requiring some component from, and I'm hitting /edge, and pretty much I'm passing it the chunk that I want, or Webpack is putting this together for us all under the hood, so we don't even need to worry, and it's responding with the rendered copy of it. So now what I end up getting is a little bit of JavaScript, which is all right, but I actually get the React app rendered. So website 2, that CPU, that process, that thread rendered this, and then my consumption of it in website 1 literally just converts it back into a React component, and that lets you do a couple things to it if you want. If we modified this slightly and we had it just do a straight module exports, we could actually do rendering on the edge and stuff like that. And that's what's really, really cool, because that edge we can't really use Federation because nobody supports VM or eval or do functions. So there's no way to actually execute a function that you stream in. But what happens if I use this new mechanism where I'm not running a function? And if module exports is just a string, I can stitch it directly into the existing Edge application, and I have this distributed system where I can personalize stuff and have the full benefit of Federation. So anyway, that's what I require over the network from the server through a render API. This is kind of similar to if you were to do a post somewhere with old school micro-frontends. You would do a post and you would get back that and some script tags. This is the better version of that. So now what's really, really cool is we're going to go to this handler. They're pretty much the same thing. And you can actually pass it properties. So I can change this to like, yes. And when I hit render, boom. So even though this is rendered server side somewhere else, I'm able to actually pass data back and forth inside of it and still just receive the string that I'm going to pretty much just set inner HTML, or in this case, I literally just parse it back into a symbol and then create an element off of it and put it back together. And that is really pretty much it. Like, there's nothing really more to say on how this works, but you know, a different CPU made this result than this CPU over here. And this really solves a lot of separation of concerns issues that have come up. Like, I can multi-thread it. You could theoretically, you could say take your pattern library and you could stitch it up to a system like this and have a render system for your pattern library, and you could fragment cache every single component, and all the Webpack stuff would work perfectly, and you'd be able to fragment cache it and also offload all the rendering effort to a different Lambda, and your Lambda can boot and run faster. And what you're really limited by is your own network. So if you did any micro-frontends anyway, you're still limited by your own network. Like, most of them are either iframed or you some kind of get post network setup. So this is pretty much a solid solution to a federation-like system. The yesteryear's one was you just return an object, parse the object, and then string replace little markers in your code. So I don't really see any problem with this. This is a fantastic setup and very powerful because I'm just doing it with strings right now. But seeing as I can now just require API data or anything like that, you could say get around the problem with suspense, where you have the data fetching suspense issue. It doesn't really come together. But what if I just required the data? Import the data. So what if I had literally, it's kind of quirky, but what if I just had, you know, like import component data consumer slash get page data or whatever. and I want suspense to not do anything until the data is ready. Well, seeing as suspense doesn't really do that, and in server-side rendering in general, we have huge async issues. Why don't we just let Webpack Federation handle it? And Federation can go out and why can't you require a JSON response? You know, as if just as anything else, module exports an object. That's all I'm doing here is module exports. In Edge World, I would just module exports the direct HTML string with nothing else, and I can still interpolate properties into it. So why couldn't I do that with data? Sure, it's weird and kind of strange to look at that, but it gets around a lot of async challenges that happen during the render, because unlike many solutions, you kind of render your app and then you go and get all the renders from header, footer, and other places. So you have a waterfall of blocking to make it actually work. But in here, as you saw throughout the code base, there's no thing like I'm even using synchronous imports. So this it gets around many problems. I'm literally able to go out and get a component over the network and stream it into a current render pre-rendered for me, so no extra computation. And I could do the same with API data, where I could literally just import an API call and have it ready. Don't have to wait for it or deal with suspense issues or anything like that. But I could just push this back to Webpack and tell it to take care of it for me. And the whole mechanism will work. So this is really, really cool. I'm not even sure like where this is going to go or how it's going to evolve, but this is just really next level for me. The fact that I can hit another CPU and require the HTML response and return it inside of my system without actually adding any change to the implementation. Your developers would do nothing more than just import header/nav. And client and server, there's other than one piece of middleware, which will probably either keep or we might even abstract it. But the only change is you drop a piece of middleware in here and the rest of your code base is still completely universal, and you don't have to change a line of code for the ability to pretty much have distributed parallel rendering with module federation. So I'm super excited. I can't even begin to imagine how I'm going to leverage this, but this is very, very, very cool. I've never actually seen anything like this. And yeah, it kind of blew my mind last night. So a big shout out to Jacob. I'm going to link his Twitter down here. Definitely a guy to follow. He's been a huge, huge heavy lifter on streaming systems for Module Federation. And definitely kudos, Jacob, because you did a really good job here. And the reason you're seeing this today is because Jacob was really passionate about it and helped me push it over the edge. So I'm real excited to see what comes with this, but it is just real cool. Anyway, thank you for watching this, and hopefully I'll figure out how I can get this to the public some way. But it exists, it's cool, and there's a lot more to come.